Okay, today we're going to do our 9-1 States of Matter particle motion notes. These are two-column notes, and you get to write them out this time. Two columns because the first column over here is usually our word, and then the second column over here is our definitions and descriptions. So the first word we're going to talk about is a fluid. What is a fluid? A fluid is any form of matter that can flow, and there are two forms of matter that can flow. Gases can flow, liquids can flow, solids cannot. So just remember, gases and liquids are considered fluids. A solid is defined as anything that has a definite shape and a definite volume. Volume meaning it takes up space. So when you think about a solid, you think of like a brick, or you think of the TV. It has a definite shape, it doesn't change, and it's definitely got a volume, meaning it takes up space. You will want to draw this picture in your notes as well, so get that drawn down. And what it's showing is that the particles of a solid are in fixed position, or they're fixed in place here. They're not going to move, and that's what gives solids their definite shape, because the particles cannot move. They simply vibrate. So there is a little bit of motion for solids, at least their particles, but not enough to change its shape. So they kind of vibrate in place. It almost looks like they're shivering right there. Solids cannot be compressed. Try it. Try compressing a brick. You can't do it because the particles are already compressed and right next to each other. Now there are two types of solids that we're at least going to talk about. One is considered amorphous. The second one is called a crystalline solid. Right? And those are a little bit further down here. Amorphous solid. When we think of amorphous solids, they have no repeating pattern. There's no order to their particles. They're just randomly placed together. You'll want to draw these down too. Look, there's no pattern. They're just kind of squished together. I think of it like morphing. When something morphs, it kind of changes. Well, that's kind of what this one is. It's kind of morphed together. Think of it like people at a concert in a park. People are just kind of randomly spread out. They're really close together at the concert, but there's no pattern. All right, they're all sitting on the lawn, or they're walking around on the lawn. Examples of amorphous solids include butter, chocolate, plastic, and jello. They have no distinct melting point. They just get softer and softer as time goes on. So that's the clue about amorphous solids. They just get softer as time goes on. Crystalline solids, they have a repeating pattern. Their particles are fixed just like this. See, they're all fixed together, nice and neat. It's like people sitting in a movie theater. They're all nice, neat rows packed together. Crystalline solids do have a distinct melting point. There's a point at which it starts to melt. Salt and ice. Think about ice. Does it have a distinct melting point? Sure it does. 32 degrees Fahrenheit or 0 degrees Celsius. So those are crystalline solids made up of crystals. Next, let's talk about liquids. Liquids have a definite volume. They will take a certain amount of space up, but they have no definite shape. They take the shape of whatever container you pour it in. Alright, so imagine I got a beaker of water. I pour it in, it's going to take the shape of whatever that beaker is, but it will have a certain volume. It might be 20 milliliters. I pour that same water in a smaller beaker, the shape changes, but the volume is still going to be 20 milliliters no matter what. That's a liquid. So it does take the shape of whatever container, and the particles will slide past each other closely. They are moving around just a little bit, and you'll want to draw this picture right here. It does move around a little bit, which is why liquids can flow and they can actually move around, is because of that. Finally, gases. Gases have no definite shape, no definite volume whatsoever. They will take the shape and volume of whatever container you put it in. You spray an air freshener in the room. Think about it. That freshener spreads out across the room quickly. If you're on the other side of the room, within seconds you're going to start smelling it. That's because the gas is taking the shape and the volume of the room that you just sprayed it in. And it's going to continue outside into the hallway and wherever else it can go. You'll want to draw these pictures here. A gas, its particles are really spread out, and they move very fast. Gases can be compressed, which is why when you blow up a balloon, you can squeeze that balloon, you can compress the gas pretty good. And this is why, because of all the space between the particles. Alright, last but not least, there's a video we're going to watch that just kind of re-explains the particle motion in solids, liquids, gases. But before you are finished with these notes, at some point you must answer the final question. And our final question is, using your notes you just took, what is the difference between a solid, liquid, and gas? Just make sure that when you go to describe it, you're also describing how the motion of the particles are for each of those three states. Okay, so let's take a look at my little video I put together for you. Maybe. There we go.
Alright, today we're talking about the states of matter and how particles are arranged. Well, I got this nice, fun, handy-dandy bedbugs game here to help demonstrate how the particles of solids, liquids, and gases look. So first of all, let's take a look at solids. We already said that they have a definite shape and a definite volume. Now, their particles are in a fixed position, and they just tend to vibrate in place. So think of it kind of like our little bedbugs that we have right down here. We can see them, they're in place, and as soon as I turn this on, you're going to see that they're vibrating in place, and they're not really moving around. They're kind of fixed in position. So here we go. Alright, so there's solids. Now we're on to liquids. Liquids have a definite volume but no definite shape. They will take the shape of whatever container they're in. Now their particles are a little bit different. They can slide past each other slightly. Alright, they can kind of slide back and forth, floating around within their containers. And of course that's why liquids can flow and easily change their shape because of that. So let's see how liquids particles are demonstrated. They're moving around a lot more freely than the solids, which is again is why they can flow and take the shape of whatever container they are in. Last but not least, we're on to gases. Gases have no definite shape, no definite volume. They take the shape of whatever container they're in. And in this case, their particles are free to move wherever they want. They move very fast, and they are basically bouncing around each other. Think of them like super balls that are easily compressible, just flinging around everywhere, and we can demonstrate that with the bedbug game too. Alright, so you saw those guys, they're floating all around, they're free to go wherever they want. Those are the different particles of the states of matter.
Okay, that's the end of our notes. Don't forget, answer the final question. Come into class ready to answer that, because I'm going to go around the room and call on people and see if they know the answer. All right, see ya.